So in some previous videos, I gave focus to the standard normal distribution. So the standard normal distribution, we use z for our random variable, say that it's normal and centered at 0 and 1. And that's great to have a good understanding of the standard normal distribution, but there are many other options for a normal distribution. In all other options, I'll use something other than z for my random variable, such as x, and I'll need to give you a value for the mean and the standard deviation. So for these examples, I'm going to use, let's see, a mean of 100 and a standard deviation of 20. And I want to make sure that we can use the normal CDF function and the, the inverse norm function. I pause because I sometimes use Excel, and in Excel it's just the opposite. It's inverse norm as opposed to, the norm inverse as opposed to inverse norm. So one option, just to be clear, z-scores are sometimes called a standardized or a standard score. If you have a value of a random variable that may be from another normal distribution, such as the one here, and you want to convert that to a z-score, you can do so using this formula, z equals x minus mu over sigma. So I could take a value from this distribution, like let's say x equals 125, and I could transform that so that it is to see its equivalent z-score by taking z equals 125 minus 100 over 20. So that's 25 over 20, which is 5/4, or 1.25. So let's see. If I started out with a question where I wanted to know what's the probability that a random variable x takes on a value greater than 125, I can convert this to a z-score, and that would allow me to instead answer what's the probability that a z-score is greater than 1.25. So that's the value I found here using the computation. Or let's say if I wanted to, what's the probability that x would be less than 88? I can convert 88 to a z-score by saying z equals 88 minus 100 over 20. So z equals 88 minus 100 is negative 12 over 20. Let's see, those are both divisible by 4, and so that would be negative 3/5. So I could instead answer what's the probability that a z-score is less than negative 3/5, which is negative 0.6. Okay, and then you could just go to your calculator and use the normal CDF function with 0 and 1 for mu and sigma. But with a TI-84, you can actually skip this conversion if you want, and we can answer these questions directly using the normal CDF function. So the probability that x is greater than 125. So first of all, let me just draw us a little picture here. Here's a normal curve, not standard normal. The center for this distribution is at 100. So here's 100, and each standard deviation is 20 units. So this is 100 plus 20. This would be plus another 20, plus another 20, and on the left-hand side, I'd be subtracting 20. So the probability that x is greater than 125. So 125 is somewhere over here. This is a greater than question, so I'm finding the area that's to the right. So in my calculator, I need to find the normal CDF, and let's see, the left-hand bound, so where this area starts, is at 120, and where does it end? Well, it goes on and on forever, so I'm going to use my really big number, 10 to the 99th, and the mean here is 100 and the standard deviation is 20. So normal CDF, 120, comma, 10 to the 99th power, comma, 120, close off the parentheses, and that's 0.1587, just rounding at 4 decimal places. Let's see if we wanted to answer this question, x is less than 88. I'm going to just recycle this same curve that I have drawn. 88 would be somewhere about maybe right here, and this is a less than question, so I'm going to shade the area that's to the left, and I'll use normal CDF, and the smallest value that is included here, well, there's no limit, it's negative infinity, so I'm going to use negative 10 to the 99th power, but the right hand, or upper bound, is 88. This is centered at 0 with standard deviation 20, and so I'll use the normal CDF function again with negative 10 to the 99th power, and 88 is my cutoff. My mean is 100, standard deviation is 20, and this is 0.2743. And we could also answer a question, such as, what's the probability that x would take on a value in between, maybe, I'm just going to very unoriginal here and say between 88 and 125. And for that, I can use my normal CDF function with a lower bound of 88 and upper bound of 125, centered at 100, that's the mean, standard deviation of 20. So normal CDF, 88, 125, 120. And that would be 0.6201. Now notice, that's this area that I want to shade with black. Another way to find that, I could have just taken this result, which was the 0.1587, and this result, which was the area in blue. If you add those together, that's everything but the region in black. So just to illustrate, if I take 0.2743 and add 0.1587, I get 0.4333. But if I subtract that from 1, what have I done here? 0.88, 88, and 125. Those should give me the same answer. So let's see what I did. Let's see. Let's redo this one with 88. So normal CDF, negative 10 to the 99th power. Oops. Clear. 99th power. I want to go up to 88. That's 0.2743, so that's right. And then let's check again on 125. So distribution, 125, 10 to the 99th, 120. Somehow I made a mistake there. That should have been 0.1056. Okay, so when I add those two together, plus 0.2743, the sum of these two values is 0.3799. Now if I subtract that from 1, yeah, now I get the answer. Okay, so the point is that if you want to combine two areas, you can just add them. But don't forget our complement rule. So that's what I'm using when I subtract from 1. Alright, so I think that's good for this video. Join me in the next, or in a follow-up video, And I want to give you some context, so an application of the normal distribution. I hope you will join me then.